What is a neutron star? Imagine a star so dense that a single teaspoon of it would weigh billions of tons. This is not science fiction. This is real. And it's one of the most extreme objects in the universe. A neutron star is what remains after a massive star dies. When a star runs out of fuel, it can no longer support itself against gravity. The core collapses violently, and the outer layers explode in a powerful supernova. What's left behind is something incredible. A neutron star. It may be only about 20 kilometers wide, but it contains more mass than our sun. That means all that matter is squeezed into an unbelievably small space. So what makes it so special? Inside a neutron star, atoms are crushed. Electrons and protons are forced together, forming neutrons. This is where it gets its name. A giant ball of neutrons, packed so tightly into that normal physics starts to break. Gravity on its surface is incredibly strong. If you dropped something from just 1 meter above it, it would hit the surface at millions of kilometers per hour. You wouldn't just fall, you would be slammed into it. But the story gets even stranger. Neutron stars spin, and they spin incredibly fast. Some rotate hundreds of times every second. These are called pulsars. As they spin, they emit beams of radiation from their poles, like a cosmic lighthouse. If Earth happens to be in the path of these beams, we detect regular pulses of energy. That's how we discover many neutron stars. But this is only the beginning, because neutron stars are not just dense, they are dangerous, extremely dangerous. Let's imagine getting close to a neutron star. Even from a distance, its gravity would begin to affect you. The closer you get, the stronger it becomes. Your body would feel extreme forces, just like near a black hole. You could be stretched by tidal forces. But that's not the only danger. Neutron stars have incredibly powerful magnetic fields, trillions of times stronger than Earth's. These fields can distort atoms. They can even affect the structure of matter itself. If you came too close, you wouldn't just be pulled, you would be torn apart at the atomic level. And then there are magnetars, a special type of neutron star. These are the most magnetic objects in the universe. A magnetar's magnetic field is so strong, it could wipe out data from a distance. It could damage electronics, and even affect human biology. Now imagine standing on a neutron star. If that were even possible, something strange would happen. Because of its intense gravity, your weight would increase massively. A small movement could launch you at extreme speeds, and the surface itself is believed to be incredibly solid. Harder than anything we know. But here's something even more fascinating. Time behaves differently near a neutron star. Just like near a black hole, time slows down. This means that for someone far away, time near the neutron star appears slower. Another example of how extreme gravity affects reality. Neutron stars are also responsible for some of the most powerful events in the universe. When two neutron stars collide, they create a massive explosion called a kilonova. This releases huge amounts of energy and creates heavy elements like gold and platinum. Yes, the gold we use on Earth may have been formed in collisions like these. So neutron stars are not just destructive, they are also creators. They help build the elements that make up our world. A neutron star is not just a dead star. It is a reminder of how extreme the universe can be. A place where matter is pushed to its limits, where gravity dominates everything, and where the laws of physics are tested. The universe is full of mysteries, but neutron stars show us something important. Even in death, stars can create something extraordinary. And maybe moon. There are still secrets inside them, waiting to be discovered.